Hi, everyone. I'm Meghan Heintz. I'm the matriarch of Spellbook. Um, I'm super excited to be here because I know, from context clues, just by being in this room, you guys are some of the brightest minds in blockchain analytics. And our job at Dune, as our CEO so eloquently put this morning, is really to just build tools to make you more and more powerful data scientists, analysts. And I know as a data scientist, that a really fundamental tool in your toolbox is being able to build and collaborate and maintain and create new views and tables. And that is exactly what Spellbook is for. So you may have noticed when you were walking in, there was a fairly long list of prerequisites for this workshop. I don't want you to fuss, though, because we have lots of people here to help you. All of our workshop elves are going to raise their hands right now, so you know where they are. So if you run into any issues, just lock eyes with them and they will come running to help you. And this is going to be an interactive session, so definitely I see many of you already have your laptops out, so that's good. But I always think it's good to start a workshop with kind of understanding where everyone is in their data journey. So I want you to raise your hands if you've ever queried either DEX trades or NFT.trades. Cool. Everybody. And how many of you knew that Spellbook or abstractions, the previous version of this project, is where those tables were created? Okay, still the majority of you. And how many people have successfully contributed to either of those projects? Oh, that's actually more than I thought. Okay, great. So that's very exciting. I'm hoping that we can go on this journey together and everyone will be able to raise their hand for that last question as soon as possible. So Spellbook, previously called Abstractions, is our Web3 community data transformation project. So I'm sure all of you are aware of the terms ETL and ELT, and T, transformation, is what we're doing in Spellbook. We've made this big maturation of our project by converting our repo into a DBT project, data build tool. And DBT is basically an open source analytics framework that tries to take kind of the best practices from software engineering and bring them into analytics engineering. And what I mean by that is now we have dead simple data quality tests we can add in like essentially a single line of code. We have some maybe slightly more complicated but incredibly useful unit tests that we can write on our models and our queries. We can now do materialization in a simple configuration block rather than writing kind of these increasingly complex P-SQL functions and cron jobs that you can't actually test yourselves. All you'll actually be writing is select statements and then defining your materializations simply in a few lines. We also have auto-generated lineage or dependency graphs, which maybe wasn't so clear on the other wizard side, but it's kind of a big headache for us on V1 because we had these complicated mind maps of the order that we had to deploy things in, and now that's all managed automatically for us by DBT. We also have automatically generated documentation. I'm sure if you've been writing code for any amount of time, you've written an errant comment in a file knowing that it was incredibly important, but no one was going to see it because it was trapped in a comment statement. That can now be written into the documentation that can be rendered in some fairly beautiful UI as close as possible to the code itself. And we also are implementing Jinja templating and macros, which means we can write much more elegant and modular SQL code rather than having to copy the same thing over and over again. We can do interesting things like write for loops and define variables. So a lot of exciting stuff when we've upgraded from abstractions to Spellbook. So today, we're going to do a couple things. We're going to set up DBT, and our workshop elves are going to be incredibly helpful to you in that process. We're going to learn how to migrate a spell, and then my colleague Thomas is going to tell us a little bit about our newly launched labels project. Cool. So we're going to do these prereqs. I'm going to go through them fairly quickly, but then we're going to take a little bit of a break while everyone catches up. So raise your hand if you need help from an elf, and then give me a thumbs up if you've gotten through everything. We'll kind of wait until most people have a thumbs up, and if at the end you're still kind of stuck on something, you're going to get cozy with one of your neighbors and make a friend and follow along with them, and we will help you after the workshop. So I'm sure most of you, but some of you may not have already gotten with it. So you've got to sign up for GitHub, but also set this up locally, including authenticating between Git and GitHub. You have to fork our repo and clone it locally and kind of load it up in the IDE of your choice. VS Code is a nice one. I'm personally a PyCharm person. Alan laughed at me when I said that yesterday, so maybe I'm the only PyCharm person. But use whatever you feel most comfortable with. Then we will set up the DBT prerequisites, which includes installing Python 3. If you have not installed Python before, grab a workshop elf now, and they will sit with you and help you get that done. Install pip, install pipinv. Pip is our Python package installer, and pipinv is the virtual environment manager that we selected for this project. Then we will set up DBT. So we'll do that by installing the virtual environment for this project using pipinv install from the root of Spellbook, the repo that you have just cloned. We'll open the virtual environment with pipinv shell, and then we'll set up DBT with dbt init, which helps define the project YAML file that you will need to run this project. And I'm going to give you the link for all these slides when we get to the break, so don't worry too much if we're going fast through this. dbt init, we're doing something a little funky with this because we're kind of half setting up the project because unfortunately we cannot give all of you direct access to our database. So when you go through this setup, there's going to be a few placeholders and a few things that you have to do. So we're working with the Databricks database, but for host, you can put whatever you want. I just put a period as a place marker, HD path, same thing, token, same thing. But for schema, you must use the schema wizard because we're doing some kind of magic on the back end with that. And then threads, the same thing, doesn't matter. So just make sure you use wizard as a schema and use whatever placeholders you want for host, HTTP path, and tokens. After you do that, you're going to run dbt compile. Just make sure that that succeeds and gives you this done message. And then you're going to ensure that that has created a new directory for yourself called target. This is going to contain your compiled SQL. So later we're going to write some SQL plus some Jinja, and this is going to convert it back to plain SQL for you. Don't run dbt debug. That's checking your database connection. You don't have a database connection, so it will fail. Cool. These are the slides. We're going to take a little break right now as we set this up, and all of our colleagues are going to help you do that. So just let me know, give me a thumbs up when you're done with this setup, and then we'll continue the presentation. Cool. Everyone, if you're not finished, this is the time where you have to get cozy with one of your neighbors that did finish. So good friend-making opportunity. Does that sound good? All right, we're going to try to actually build a spell now. So we're going to do a migration because we all already know SQL super well. We are just going to take something that was already written and convert it into DBT. So I've selected view balances from Balancer. I tried to be kind of egalitarian and pick a random project so I wasn't showing too much favoritism. And this is the one that I landed on. You can find the V1 version under deprecated Dune, V1 abstractions, Ethereum Balancer, view balances. Either navigate to that in your locally cloned repo or on github.com. And then we're going to go back into Spellbook and set up a file structure. So you're going to add a project folder for Balancer, and then underneath that, Ethereum. So we're going to do all chain work in the chain directories, and all cross-chain work lives in the main project repo, or project directory. Then we're going to create 3 empty files, one being your spell file, so balancer ethereum balances.sql, balancer ethereum schema.yaml, which is kind of where you're going to describe what your spell is doing, and then a balancer ethereum sources YAML, which is going to describe the dependencies that your model has. So the first step is super easy, just copy and paste. So copy the old abstraction, paste it into the new file you created, balancer ethereum balances.sql. The next step is also pretty simple, just deleting stuff. So we're going to delete everything out of that file that is not the select, or in this case, a with statement. So drop materialized view, create, index, all that stuff can go away. We're going to handle that later in a very simple dictionary, basically. Next thing is a little annoying, but we did move from Postgres to Spark SQL, so we have to make some syntax changes. I think they're going to be fairly simple for this particular query. So the first thing is just removing double quotes around table names, replacing double quotes around reserved keywords with backticks, and replacing the /x with 0x, and lowercasing the addresses. Also later in the query, there is some syntax for generating a series of dates. In Spark SQL, this just becomes explode sequence. So I think that is all the changes you're going to have to make in this query. But Boxer has written up a very nice, comprehensive overview of all the changes between PostgreSQL and Spark SQL. So also, because we are a workshop and we're running short on time, you can speed up your SQL test by using event transfer sample instead of the full event transfer table. I would recommend doing that. And then once you've made those syntax updates, which should be relatively quick, what you're going to do is just copy that SQL and run it on Dune.com and just make sure it runs, make sure the data looks good. We'll maybe give you like a couple of minutes to do that, and then we will continue on and show you the actual DBT components of this. Okay, cool. Now we're going to do the actual DBT component of this. If you don't have your query running at this point, that's all right. We can just talk through this. So this is the first time we're introducing Jinja into our spell. But all of our tables we're going to replace with sources. So you've got your curly bracket to denote a Jinja block, and then a source with the schema and table name. So we're just replacing all of our tables with this. A source is just any table that is not made in Spellbook. So you're not referring to anything else we created in this table or in this repo. You have to define your sources in a YAML file. If you're using a commonly used table like Ethereum transactions or something like that, it's definitely already defined. But if you're using probably a decoded table from your project, you're probably going to have to define that yourself. This is kind of like as much work as you want to do on it. There's bare minimum where you just have to say what the schema is in the table name, but you can also go ham on this and write really nice descriptions of the table on all the columns. You can define source freshness tests, which is kind of an extra layer of security that guarantees your data is up to date. And you can also write custom tests against these sources. A nice thing about contributing to this is this automatically goes into our documentation, which has this kind of nice little UI created by DBT. So this is also the place where you might be able to say you're the contributor or write a nice little ad for your project describing what it's doing. At this point, you would run dbt compile again and check for really common errors like missing a source or kind of like a simple YAML syntax error. We don't do this in the spell, but if that query had referenced another abstraction or spell, you would use something called a ref, because there's two different ways to refer to tables. And a ref is just another file in the Spellbook project. In this instance, I kind of just pulled out one of the CTEs, put it in its own file, and then I can refer to it simply by the file name. But you don't need to do this to complete the spell. This is just kind of something you should know about. And then we're kind of like in the end of this process. So we're really just defining the alias, which is the name of the table, the schema, and the materialization. So back when we deleted all that like index stuff and create materialized view, all we're doing to replace that is this single line materialized view. If you had wanted to make a table, it would just say table. If you want to make incremental, it would say incremental, and there'd be a few more Jinja blocks throughout the SQL query, but it's a little more complicated, so I won't get into that today. Generally speaking, best practices, always try to build a view first, because then you're guaranteed to have up-to-date data. There's no lag between updating your table or materializing it anywhere. So always start with a view, but if we need better performance, we can work with you to create tables or incremental tables. And then we just define what we did. So we add our table to our schema file, we write our nice description, we give ourselves a pat on the back by adding ourselves to the contributors section, and then we can also add tests with a single line of code by just adding in tests and the name of the test we're going to run. DBT ships with a bunch of generic tests like checking for null values, checking for uniqueness, key relationships between tables and accepted values. We're writing new generic tests, which Jeff has contributed to, that are very specific to our domain. So it's going to be very simple to really improve and guarantee the data quality of your work. Again, you would run dbcompile because you've added YAML. And then you would go to the target file, which is going to take all your SQL that you've added gingerblocks to and turn it back into SQL. And you can just double check that it's still running by pasting it into DuneCon and running it. This is kind of a wart, and we're going to remove this imminently. But to make your table or view visible on the Dune Data Explorer, you're going to write a quick little set table properties snippet inside this file called alter table properties. I think we're going to replace this in the next 2 weeks, so I hesitate to show you something so ugly. When you open this table or this file, you'll see how long it is, but we are always improving this process, so don't worry too much about it. At that point, you're ready to just push your code and open a pull request, and my man JDude will help you out. That's it. You can celebrate. You've done it. Just in summary, we set up some prereqs. So we got Git and GitHub set up. We set up Python, pitinf. We made our file structure with our SQL schema and source files. We converted everything into a Spark SQL select statement. We used some gingerblocks to define sources. We defined the name or alias of our table in a simple configuration block, our schema in the DBT project YAML. We defined a materialization, in this case a view. We didn't have to write a crazy pSQL function in cron job. We added a simple test, and we made a pull request, and one of you will be merged, and that's it. You're an arch wizard. You're the most powerful wizards on Dune. We are obviously all worked on the same query. So I think in about a week and a half, we're going to go through all of your pull requests, and whoever gave us the best pull request is going to get merged in, and we're going to send you a nice little prize. So at first we thought maybe we'll do the person who gets it in first, but then we realized that's not really the type of work we want to incentivize, because we want people to do thoughtful, useful work. So we're giving you a week and a half to finish this. We can tweet out the more details about that after this. But at this point, I'm going to pass this over to Thomas to talk about labels.
Hi, everyone. Yeah, I just wanted to take this opportunity to talk about spells. And one of the cool things we've done lately is we just launched the very first version of labels on Dune v2. For now, it just includes centralized exchanges, some funds, some top NFT traders, and some other things. But those are more examples for you to get inspired from and hopefully help us get a lot more labels in there. So we kind of need your help to test it a bit, give us feedback, add some labels yourself. If you ever have some queries with a lot of addresses, well, you can now take them, add it to labels really quickly, and that will help the community and us, and that will just help us. So how to use it? You just basically use the get labels function in any of your queries, and instead of the address, you'll get the labels associated with that address. And what's cool is on v2, labels are actually spells. So since you all know how to build spells, you can also build labels. We have 2 types of labels mainly. You have static labels, which are basically lists of addresses, like pairs of addresses and names that you can just like manually enter. And then we have like query labels that are basically based on spells. So you like use spells to create new labels. And so both are super useful. And it's kind of like a cool circle, because like the more spells we build on Dune, the more labels we are going to have, and the more query labels we are going to have. So we can have some like kind of like an intuitive feeling of what addresses are doing and what their activity and stuff. So yeah, I just kind of wanted to ask you all to come to me and contribute to labels and help us and give us your feedback. What's next for labels? Well, more labels. We're gonna also like try and customize the get labels function, and hopefully do some cool educational content on how to use labels to make your dashboards look better, hopefully. Yeah, thank you everyone.